Well, hey all. Thanks for joining today for this anti-cast called Cloud Identity Management for Everyone. I just put the Cloud and Identity Management for Everyone on there. This is a topic that is near and dear to me because I have spent the majority of my career focused on identity in one form or another, including strange things like NT 3.5, Novell NetWare, eDirectory, Active Directory. And now, of course, I specialize in cloud stuff. I'm Andrew again. I lead the security advocacy team at Datadog. If you're familiar with Datadog Security Labs or the research reports that we do, those are all things that my team is responsible for. I also have the pleasure and privilege of working with this team at Antisyphon to teach the Securing the Cloud Foundations class, and hopefully, we're going to get that on the schedule for some public offerings later in this year. I also did a bunch of work early in cloud around forensics automation and worked as an incident responder. So I have lots of great war stories to tell about crazy incidents I worked on or helping folks out on some of the worst days of their life. Yeah, somebody said, you don't look that old. I promise I touched Novell NetWare a lot of times, but NetWare was old when I started my career. Just a little disclaimer here. I speak a lot on behalf of Datadog. These are my opinions in this presentation, not Datadog's opinions about IAM in all three clouds. So I'm going to call out some gaps in features and do a little bit of comparison of providers. Not really for the sake of saying that any one is worse than the other. It's really more to get you familiar with some of the fundamentals in all three clouds. And I think this talk is exciting. I had a lot of fun putting it together because I've never seen anybody kind of compare the various capabilities and potential pitfalls across all of the cloud providers. Now, notably, I might get something wrong. I have been a practitioner in AWS and Azure, or AWS and GCP. I have never run a production environment in Azure, so had to do a fair bit of research and lean on folks in my community to answer some questions. Today, though, we're going to look at history of identity management. We're going to look at different models for identity and access. We'll kind of put together a little bit of a comparison of what capabilities exists in each cloud. And then we'll look at the biggest potential pitfalls and how you can address those regardless of the cloud that you operate in. I don't know if anybody here is willing to say what clouds they're in, like whether you're in AWS and Azure, AWS and GCP. It used to be that I would tell people when I taught the Securing the Cloud class, whether you know it or not, you probably have some presence as a company in the AWS cloud. But I feel like now it's actually incredibly common to have AWS as the cloud that you're running compute in. And then maybe you also have O365 or M365 and Entra ID, formerly known as Azure AD. So just a quick history of identity and access management. We didn't always call it identity and access management. It's existed for a long time, right? So the original concepts of access management went all the way back to 9/11 BC. They figured they found the first key for a door. And that was a long time ago. And then we sort of started to evolve that into what became passwords. And if you're familiar with identity providers, way back, like in books of the Bible, there's references to somebody going to a gate and saying the word shibboleth to gain access to something. And then, of course, in the 1920s, we had speakeasies where people would go and they would say the passphrase to get in somewhere. And then during World War II, actually paratroopers would do a challenge and response where somebody had to give the right challenge and then they had to give the right sort of a passphrase back in the form of a response, and then they knew that they were good to jump. So really, like, identity and access has been present as concepts, and I think the concepts are most important, especially as we think about securing things in the cloud, because a lot of these concepts don't change regardless of the implementation or the system. Yeah, anybody that's worked in education at a university or something has probably seen shibboleth. It's very, very popular in academia. So then come to 1960, we actually started to have the first computer passwords. And then in 1996, and I actually didn't know this before I built the talk, was the first instance of second factor auth. And it actually came in the form of messages sent to pagers. And you would go and you would type those in on a punch code phone. And then, of course, in 2000, when Microsoft released Active Directory, for 2000 server, that was the first time that we really truly had single sign-on, because things started to become, Kerberized, and you could pass around kind of this magic token that would get you access persistently rather than having to type in usernames and passwords when you access different file shares. Of course, today, now we have modern identity and access management systems, which are incredibly complex. They are very hard to reason about for a number of reasons. It's largely just because humans don't really think in terms of how an access decision facility is going to evaluate the result of a bunch of different policies. They tend to think in terms of, I need to do this and I need to grant that. And so, I don't want to have to come back and do this. So I'm just going to grant this really big basket of permissions. And then I don't necessarily have to care about this. So we're going to look at these three clouds in this. And that is because credentials are still the #1 cause of cloud breaches. And it's really not because, we're just bad at managing credentials. It is because credentials are often overly permissive, and we use forms of these credentials that are incredibly long-lived, or worse, live forever. And that generally results in a pretty significant impact when we start to pair those two things together. We have this dangerous long-lived credential and a lot of permissions that are associated with it that allows a threat actor to privilege escalate, move laterally inside the environment, exfiltrate lots and lots of data, waste money, spin up resources, etc. So the things that are common to all of these cloud environments, right? We start with the most common things. So you may have heard the term AAA before when we talk about old school identity and access management. So if you worked in Cisco land or with Radius servers, we talked about authentication, authorization, and accounting. So authentication is who you are, authorization is prove who you are, and then to some degree, what can you do with a credential? And then beyond that, on the accounting side, we log the actions that a user takes when they're authenticated and authorized. That's that last A. And AAA, and that's a super important one, increasingly important, as we move to the cloud, because oftentimes those accountings are the only way that we can tell the story of what happened in the event that there's actually an incident. To make matters a little bit more complicated, because identity and access management is hard, we have privileged access management, which is supposed to be a family of tools that help you get to a least policy privilege on top of an access decision facility. Then you have the access decision facility itself. And this is a term I think a lot of people aren't necessarily familiar with. It actually comes from one of the NIST frameworks, and it's just meant to reference how a cloud makes an access decision using the combination of all the different policies to say whether that access is allowed or denied. And depending on the cloud, that set of steps, the decisions, and the different policies that can beat one thing or another get more and more complex, because we don't just have one policy system often in cloud. We tend to have 2 or 3. And then also zero trust has kind of come into this as we've evolved things, which is this idea of continuously verifying access inside of a complex system. So beyond that, before we can have the conversation, we also have to define a few more things here. So anytime that I use the word principal, that is going to be the entity inside of the cloud environment that makes an API call. Now, some people think that this is often only humans, but actually these can be machines, Principals can be other cloud provider accounts. They can be federated setups. In addition to that, we have the session's context. So what are the other things that we can know about how that user is coming in? So what IP did they come from? Were they using multi-factor authentication? Did it come from inside of a cloud provider account, or did it come from somebody else's computer? All of these clouds that we're looking at use a system called role-based access control, which is a way to delegate permissions based on a job function. So, of course, I work a lot in AWS, so I will reference a lot of the AWS concepts, but really the concept of role-based access control is not new. And this idea of creating job-related roles, and I don't mean a human job that you get paid for, I mean the actual tasks that an entity needs to carry out, that is a common concept across all three clouds. And then also we're going to talk about some scenarios where you can use attribute-based access control. So attribute-based access control would be delegating access based on some other annotations that we can put on a workload, a piece of data, a blob store. The simplest one is probably a tag that says, what team does this belong to, or a data classification or something along those lines. I saw somebody in the chat that just said, did I miss a lot? You have not missed much, so stay tuned if you just joined. So for comparison, what I did is I distilled down all of the concepts that I think are part of identity in the cloud, and then went and compared capabilities of each cloud provider. So just going across the top, looked at, hey, does that cloud have the concept of a super powerful super admin user? Does it have attribute-based access control? Does it have role-based access control? Can we grant permissions explicitly to an individual versus binding a role? Does that cloud have the concept of policy inheritance? In other words, do we have the ability to enforce the combination of things from the top down of a hierarchy? Does that cloud allow anonymous as a principal? So in other words, can I make things just publicly accessible and just like YOLO access to the entire internet? Does it have a policy system that is for resources and not for humans? So that would be things like blob stores, message queues, et cetera. And then also, does that cloud support some kind of guardrails so that we can say the conditions that we think should never, ever be true, or the things that we don't ever want someone to do inside of our cloud provider account? So let's look at the top IAM mistakes before we really dive in and we see how we can use all those capabilities inside of each of these three cloud providers. So the first one, and probably the most notable, because again, credential leaks or mismanagement of credentials is one of the top causes, the top root causes of cloud breaches, is actually this thing that as an industry now we're calling permissions gap. And what that means is that we've assigned a ton of privileges to an entity, and it actually doesn't use the majority of them to do the work that it does. And the way that we can know this in a lot of cases is actually by analyzing cloud provider audit logs and saying, hey, this entity has 100,000 permissions and it uses 10 of them on a daily basis. So we know that we can scope that down. So what I've done is I've linked in here as well a dangerous definition reference. And I think that defining what is dangerous inside of cloud IAM is also something that we don't see very often. But so unsurprisingly, the things that are dangerous in cloud are the things that are also dangerous in on-prem environments and data centers, which is that a specific assigned permission allows a threat actor to move laterally, allows them to escalate privilege in some way, perform additional reconnaissance that would allow them to do either of those other two things, or have some kind of excessive data access. As I mentioned, I do work on these research reports at Datadog. We actually just released the Datadog State of Cloud Security towards the end of last year, just right before Amazon reInvent. And one of the things that we found in that report from studying a ton of environments is actually that long-lived credentials are still really a pretty significant problem across all cloud providers. And when I say long-lived credentials, I just mean some sort of API key that lives forever and doesn't expire. So you can see that the majority of access keys out there are greater than 1 year old. And then following that, we got a cross section that are 3 years, or some worse, 5 years old. So that's a pretty big delta there, but there are still a lot of long-lived credentials. The corollary fact to that, of course, if we are going to have long-lived credentials, we want to have those credentials have MFA consistently enforced for their usage of them. So, of course, if somebody puts one of those things where they don't belong, we don't want a threat actor to be able to leverage that without the second factor to do stuff. But what we really see is that when people do apply MFA, they don't apply it very consistently. So in the majority of cases, we're still not really using MFA for 100% of accounts. And we talked about this a little bit on the BHS News on Monday, how there's not really a good reason anymore not to consistently enforce MFA. The other big risk when it comes to identity and access management, and this is more on the access management side and not the identity side of things, is accidental public exposure. So in cloud, all 3 cloud providers have, for example, the concept of a bucket or a blob store that you can put things in, and then it has a system to grant access to that is not regular role-based access control. In AWS, they call it a resource policy system. In Azure, they call it storage policies. In GCP, they call it something else. But each of these gives a user of that service multiple ways to grant access to a folder or a file where you could make something public. And only one of those things needs to be true in order for the access decision facility to allow access. And that's why people keep making these mistakes, is because there's all these different ways that we can configure all these blob stores. And not often folks don't understand what the resultant set of using those 2 things together actually is. And I just want to kind of define public a bit as well here. The public definition in our case that we're going to use today is that it's anonymously accessible. So either on the internet, that it's a publicly exposed port or service that just allows unfettered access, or the third, which might not be so obvious, and folks actually do make this mistake all the time, is that they think they're granting access to only users inside of their account when they're actually granting access to all of the users in that cloud. So that's actually pretty common on GCP. It's pretty common on AWS that there is this principle that's just called authenticated users. That really means all authenticated users in all of the accounts in that entire cloud provider. So those are the 3 kind of top things that we see over and over again as the root cause of data breaches or IAM mismanagement. So let's talk about prevention, right? So we kind of have this good sense of, hey, we've got a set of issues here. How, as engineers, do we begin to kind of take this apart a little bit and put some best practices in play? The first is actually to understand a little bit more about role-based access control. And on this slide here, what you're seeing is kind of a best practices role-based access control flow to go and do stuff in a cloud provider environment. So what we always have is we always have a user that has some credential. And now this could be a long-lived credential, or it could be a time-based credential that expires after a period of time. That user uses that credential to assume a role, and all 3 clouds have this concept of roles in different forms or another. And we can think of the role as putting on a hard hat or a special piece of fashion that allows you a specific set of superpowers. And those superpowers come in the form of a policy that is attached to the role. That role generates, again, a set of expiring credentials, and then those credentials get handed to the API in order to act and do stuff. And the access decision facility evaluates those credentials and then decides if you get to do stuff or not do stuff. There's a question in the chat that says, the underlined text in the slide you mentioned are not links. Aren't they supposed to be? There actually is linked in the show notes that are on the last slide of the slide deck, the entire cross-cloud matrix with all the links out to all the cloud providers documentation. So that'll be available at the end of the session, or you can just skip ahead to the last slide. So where this gets weird, right, is when we start to have explicit assignment, which is considered not a best practice. And depending on the cloud, you can actually grant access to a user instead of having a user go through, putting on that role. And so this is usually where we get more access granted to an individual, a single user with a very long-lived credential that they shouldn't always have. So by using roles, we actually force people to operate inside of the context of job functions instead of always having the superset of permissions that they need in order to do their job. So again, this flow is good. This flow is not best practices. Again, it is difficult to control, to audit. Often we end up with users that gain too much permission over time as they sort of move through job roles. And also, if we attach permissions to users instead of roles, the duplication of those permissions is prolific and harder to maintain over time. There is a couple questions in the chat about blob stores in Azure. We will get to the blob store section here shortly, so just hang on. As far as how each cloud provider implements these, it's different in every cloud, right? So AWS has a different policy grammar than Azure than GCP. So these are actually the minimum set of things in each cloud that you need in order to create an IAM policy. And you can see that there are some things that are common to all of them, right? IAM is AWS is probably the easiest because we have principal, action, resource, condition. In Azure, we have a bunch of things besides that, like not actions, so that we can do explicit denies as well on a inverse match. Azure has a couple other kind of nuanced things as well, like whether that policy is actually currently enforced or not enforced. In Google Cloud, they just go with the role binding concept instead of actually allowing that explicit assignment. But they all also have conditions, which I just do want to call out here. And the conditions is under what circumstances is that credential valid? And we'll get into a little bit more of why that's interesting and cool here in just a bit. So we're all trying to go for least privilege access, right? We're trying to get our roles scoped down as much as we can. So if somebody does steal a credential, they can't do a ton with that. So the way that we get there in every case is, again, avoiding that explicit assignment or inline privileges whenever possible, leveraging roles and role assumptions for job function by the type of activity that somebody is doing, and then forcing them to use those temporary credentials. So in AWS, it's called STS assume role. Azure actually allows this through service account impersonation, which if you're an Active Directory user, you might be familiar with that. And in GCP as well, we have the concept of role binding, but we also have things like service account impersonation, where we can actually set up these sort of job function-based things, and then an engineer can sort of toggle which role they want to operate in to do their very specific jobs. So again, that means that we have to tailor the roles and proliferate roles for the functions of the jobs and not the person. So choosing the right access tends to be what's hard for a lot of people. And when in doubt, when you don't know what the right access is, you can leverage tools to tell you what's right. And so this is where the ecosystem sort of gets a little bit bifurcated. So in AWS, there is a ton of stuff in the open source ecosystem for linting IAM. Some of the cooler open source projects that are out there are PMapper, the principal mapper, which allows you to just generate IAM policies from plain English. There's the Cloudsplaining project, which used to be a Salesforce project, now archived. It's going to be taken care of and curated by someone else here very soon. And then IAM Spy is kind of an open source version of AWS's Access Analyzer. So I really like Access Analyzer because it's a free feature that you can just kind of enable in your cloud, and it will tell you if you have dangerous access conditions. Recently, they did announce some premium features that now cost 20 cents a user or role per month. So depending on your use case, that can actually add up pretty quick. In Google Cloud, there actually isn't any open source stuff that I could find that's out there and popularized for linting IAM policies. But Google Cloud actually has its own API for policy analysis, where you can actually propose changes. We'll tell you if those changes are dangerous or if they match against a known anti-pattern. GCP notably does not allow the dangerous star principle, which just means anonymous or everyone. So applause there for that. However, Google Cloud does make it very easy to grant access to everyone who has a Google account ever for any resource. And so that's kind of the trade-off there. On the Azure side of things, because Azure is tied coupled so closely to Entra ID on the open source side, most people are just using Bloodhound to test that. On the policy analysis side, there really isn't a commercial offering that's from the cloud provider. So this is kind of a gap that's open if you're an open source tool developer, or you want, if you're an open source tool developer, or you want to find a vendor provided solution that closes that gap. This is probably one of those places where either open source development would really help you, or going and finding a vendor that does that. And then a last piece of advice for this section is to beware the pre-built roles and role bindings. So all of these clouds have roles that are shipped with the cloud, that are the job functions the cloud provider felt like they should just include out of the box. So it's very easy for you to attach and get up and running. Unfortunately, a lot of those roles in many cases have granted more access than was intended, or the cloud provider actually pushed a policy that wasn't least privilege and allowed people to do things that wasn't intended. So I just sprinkle a little bit of caution on this. It's always better to build your own roles than it is to just take the off the shelves in the case that you really do want to get down to least privilege roles. So this is, again, one of the spaces where a CIEM, or CIEM, as Gartner is calling it now. Yeah, I know that's pronounced Kim because they couldn't pronounce it SIM because there's already a SIM. It stands for Cloud Identity Entitlement Management, or Cloud Information Entitlement Management. Basically, this is just the category now for the detection engines that are going through and evaluating the resultant set of all these policies and alerting you if they're dangerous. CIEMs also often have workflows where you can go and you can chain automations together to go and automatically remediate really dangerous things. So if you haven't looked at CIEMs, there are a number of them out there. We actually recently released one at Datadog that I think is pretty cool. But again, this is one of those spaces where a vendor product might fill a gap that's not filled by the cloud provider. So about those long-lived credentials, right? So we know that dangerous policies are dangerous. We know that long-lived credentials are bad. Not to pick on anyone in particular, but usually engineers are the ones who have long-lived credentials, right? Because they need programmatic API access on the machines that they have in order to do the job that they do on a daily basis. The fact that developers are leaking credentials is not really the problem. The problem is really more that those credentials last forever or aren't protected by second factors. So we can actually kind of band-aid that a little bit by putting condition keys on those long-lived credentials and saying like, hey, you can only use this if you're coming from this VPN, or you can only use this if you're inside of the cloud provider environment. Or you can only use this with MFA, but really we've got to get rid of the long-lived credentials as an industry from pretty much everything. The second factor part of the argument, though, is kind of a no-brainer today. So a lot of the workflows for all three clouds used to be clunky when we first sort of entered the MFA space, because we only supported TOTP, which is the 6 digits that you type in, from an app like Duo or Google Authenticator. But now every cloud provider supports multiple vehicles for delivering second factor authentication to users. So Azure has one, AWS has one, Google Cloud has one. WebAuthn tokens or passkeys that you just kind of push the button on are definitely the way to go. And then on the command line, I think a lot of people don't realize that this is out there in every cloud. Every cloud provider actually has some way that they support a PKCE-ish flow. And I call it PKCE-ish because it's based largely on the OAuth standard for public key credential exchange, where you actually have a command line tool that spins up a listener, and then it pops open a web browser. That web browser has a piece of JavaScript in it that calls back to that local listener and serializes a temporary token, kind of like a JWT to the disk. That's only valid for the time that the administrator sets for it. And then if somebody does leak that credential, one, it doesn't live forever. And then two, auto expiring, no static credentials on disk. Overall, this is a really, really nice flow that now exists in all three clouds. So what you're looking at on screen here is actually an example of using SSO on the command line for AWS, where literally the engineer just types in the start URL of the single sign-on tenant, types in a region, it pops open a browser. The browser just has one prompt that says, do you want to allow this or not? And then it makes that callback. It shows the role picker, like in an ncurses interface. You pick the role, and then it serializes the token to the right place on disk, and nobody ever had to have a long-lived credential. And I'm just showing the AWS one because that's what I had prepared, but the G Cloud CLI supports this, the Azure CLI supports this now, as well as AWS. And apologies if you are hearing the dog bark. So the other thing that is kind of nuanced here about all the different clouds is that they actually don't have the capability of enforcing MFA and policy consistently. So in AWS, we actually have a condition key that says, if multi-factor authentication isn't present, don't allow these things. And then in Azure, we actually have conditional access policies, which say, hey, based on the, whether or not a user MFA'd, we can either allow them limited access or we can allow them more access. In Google Cloud, unfortunately, a lot of this, if you're not using a external form of single sign-on, is tied to G Suite, because all Google Cloud identity is just G Suite identity at some level, except in very specific cases. Let me just grab the dog. This is my dog. He is 17 years old. It just wouldn't be a Antisyphon webcast for me without including an amp. So as mentioned, all MFA enforcement is just G Suite MFA enforcement. So whatever you can do to G Suite, you can pass on to Google Cloud, and then that trickles down to the policy level. So you really don't have that strong control. And then this gets a little bit more complicated when we chain more single sign-on providers on. So in the case that you're not using cloud provider single sign-on, or you're not using built-in accounts, all we have is what's available in the SAML assertion. So we go through the SAML flow, the SAML assertion sends a big blob of XML, And not every cloud's policy grammar allows you to differentiate on custom claims. So now we have to audit, did MFA happen in 2 different places, which is where it gets to be really important that we have MFA enforcement for 100% of things, and we're controlling that at the identity provider instead of in the cloud environment. So all cloud providers, by the way, have audit logs. This is an example of Azure's audit log. You can see in the session claim here, we actually don't get a whole lot, and I just pulled out the session context bit. We actually don't get the MFA claim as part of that log. So we're lacking a little bit of visibility there. In CloudTrail, we get this, but we only get it for actual AWS IAM users. We don't get it for federated authentication. And then Google Cloud, same thing. That MFA status actually doesn't get passed into the cloud provider's audit log as part of the action that was taken. So again, super, super limited in terms of what we have on the audit log side. Beyond that, in the long-lived credentials, credential theft from workloads is still a big issue via things like SSRF and other things. And this has gotten to be, we've raised a lot of awareness about this in the last 8 years or so. And adoption of controls for that are still on the rise. But there are a lot of ways that you can exfiltrate credentials from an instance without using an SSRF. So any other way that you can get on that box, you can potentially get credentials from a workload and then use them outside of the cloud provider environment. And every vendor, by the way, this is not specific to AWS only, every vendor has the concept of a service that runs on all VMs that just vends the credentials for that instance. So in the case of that, the best thing that we can do is actually put in place guardrails that limit the blast radius of a single credential leak from a workload. And what you're looking at on screen is actually a very cool feature that's unique to GCP, or was unique to GCP for a bit, called VPC service controls. And what this does is it actually gives you, as a user of the cloud, and I don't think that there's a ton of awareness for this, the ability to say, if this credential is not being used inside of the network that I defined in my cloud, the credential is no longer valid. And so that's actually incredibly powerful, because it means that if an attacker does get a credential from a system, they would have to use it inside of the same VPC or broad network space that that credential was issued in. The downside of VPC service controls is that it is a premium feature, and you do have to pay to implement it, likely because computationally this increases the burden for the access decision facility. On the AWS side, there's these things called condition keys. And one of the new global condition keys that I'm really excited about this year is actually the ability now to say AWS source VPC. So we can say inside of the IAM policy itself, it actually come from inside of the network that that credential was vended in. So if it came from an EC2 instance, it will no longer be valid if I just take it down to my laptop and then use it to run a bunch of recon or a tool like Paku or another cloud red team tool. Azure as well now has these things that are called role assignment conditions. So they do effectively the same thing. It's just kind of described in policy in a slightly different way, where you actually have to enumerate the subnet or private endpoint. But effectively, if we were to implement this for 100% of workloads, it would mean that there was zero impact to an attacker exfiltrating a credential. So if you want to get rid of those long-lived credentials altogether, another great way to do that is actually to restrict the creation of them, right? So in every cloud, we have the ability to do things like disable the creation of access key pairs, force everybody onto single sign-on, disable key-based access, disable things like service account key export, and then move people over onto other vehicles for vending temporary credentials. We got 15 minutes left. And with that, we're going to hit accidental public access. So we talked about the public access problem. If credentials are the biggest problem in the cloud, accidental public access is right up there. And arguably, public data is often more impactful for a company than accidental credential leaks. A couple of people ask, is that my barn? That is just a random barn that I got off Unsplash. My barn is actually nicer than that barn. But that is a cool antique barn. Definition of public access, again, for today is that we allow access via the anonymous service principle on the web via a port exposure, or accidentally grant access to everyone in that cloud provider instead of just our staff. Generally, when we talk about accidental access, it comes from blob stores, and we're just going to pick on blob stores for this, but you can make a lot of things public inside of every cloud. When we studied this year, we actually looked, and the adoption of account level controls is actually increasing. So on the AWS side, a lot of folks are using public access blocks now, so you actually can't accidentally make things public. On the Azure side, they actually have an equivalent control that's gaining adoption, but it's still pretty low. It's only enforced on little more than 20% of accounts. And unfortunately, public access is a feature. So every cloud provider that started blob stores started marketing them as ways to host static websites, which is a totally valid use case, right? But what you need to do is actually govern the access of those public buckets. And every cloud has recommendations on the right way to do this. And then they also have a bunch of other ways to do it. And here's why. So in the normal identity and access flows that we've talked about so far, you have a user, that user has a role, the role is bound, has a policy bound to it, it's a credential and an action. Unfortunately, when we talk about public access, this has to work the other way around. We don't know who the principal is that's going to be accessing the data, because it could be anonymous, it could be public. So what happens is when the request comes in, the resource itself evaluates a policy that is bound to the resource that dictates under which conditions is that access allowed. So is it allowed to anonymous? Is it allowed if we don't trust the account, even if it's outside of our billing organization or boundary? And then it will either return a access denied, or it will carry out the action. Every cloud provider now has these account level global policies that you can set that disallow public access. The problem is, depending on the age of your account or how long you've been a cloud customer, these things aren't opted into by default. So you need to go and check these settings. AWS has them on by default for all new accounts. Azure has the ability to enforce it, but again, it is not on by default. And then GCP also has this, and you can do it either at the project level, the bucket level, the folder level, or for an entire organization. If that wasn't complicated enough, though, all 2 out of the 3 cloud providers support individual file ACLs within buckets. So AWS formerly supported this as a way that you could mark individual files as publicly readable. Now that's actually a disabled setting on brand new buckets that you create. The bad news is that it's enabled on all the buckets that you created before it was off by default and considered a legacy setting. In GCP, you also have the ability to have individual file ACLs, but you can turn it off. And my recommendation, and this is my opinion, is that ACLs make it so much more complex to audit what is and is not public, because you actually have to traverse the contents of the bucket and then enumerate all those ACLs versus just looking at a JSON policy and then being able to evaluate whether that grants unintended access. So the recommendation is to disable ACLs whenever you can. And then final recommendation for that is actually keep it simple and architect for auditability. So this year, I actually got to give a talk at AWS reInvent with a company called Tally, who did a big PCI architecture in the AWS cloud, tons of Kubernetes, And the coolest thing that they actually did was just segment the environment. So they had one account that was for PCI stuff and one account that was not for PCI stuff. Same thing with public. It's really easy just to create kind of an island, regardless of your cloud, that has the public stuff in it. And then, if you're auditing and you run across an bucket policy, ACL, et cetera, that's intentional. At the end, if I have time, I'll answer some use cases about ACLs that are coming up in the chat. So home stretch here. All these clouds have a concept of what I call a guardrail system. So guardrails, loosely defined, this is the way that we define it in the securing the cloud class as well, are the things you never want to have happen inside of your cloud provider environment. So we could all define probably 2 or 3 things that we're like, hey, we never, ever want anybody to be able to do this. And that's why it's a good guardrail, because we can confidently say never, and somebody doesn't bump into it very often. If you bump into guardrails a lot, you probably have guardrails that are too tight. So in terms of cloud providers, every cloud provider has the concept of what we call a multi-account system. And this came about years ago because people wanted to be able to have multiple accounts, and they wanted to be able to pay the bill through a single bill. So in AWS, this used to be called consolidated billing. In Azure, it's called account subscriptions. In Google Cloud, Google uses this resource hierarchy and everything rolls up to one big fat bill anyway. They all have different security capabilities though. So on the left there, you got AWS organizations. On the right, you got Azure subscriptions. And then on the right-hand side of this slide, you got the Google Cloud resource hierarchy, which has an organization, folders, which might look kind of like OUs to you. Then they have projects inside of them, and those projects have resources. So Azure notably does not support restriction of specific actions at the organization level yet. So feature request, if you want to put that into the Azure folks, it would be a nice value add if they did. In the case of AWS and GCP, though, they both support what's called service control policies on the AWS side and organization policy on the Google Cloud side. And what that allows us to do is it allows us to deny certain API calls with conditions. So you can think of this as the inverse of a grant. We're defining what should never be true. And what I recommend to people, if they have never done this before, is just starting with easy stuff. Start with things like, hey, I know I never need to run workloads in Sydney, Australia, or Japan, or I'm only in this one region. Or restrict the instance sizes that you know are dangerous. So if you're not a company that does data crunching on the biggest GPU instances, you turn it off. And then if an attacker gets a credential and is trying to do cryptocurrency mining and spin those up, they're going to get access denied, and you're not going to see that impact directly on your bill. We can also use SCPs and org policies for things like public access blocking. And again, if you don't want to have those long-lived static credentials, you can actually just deny that at the root of the organization instead of having to go through an audit and mop up and remediate on an ongoing basis. So there's a bunch of other use cases as well. The biggest piece of advice that I could give you is if you do decide to do this in your cloud provider environment, always use infrastructure as code to manage these policies, because you want them to go through an approval process, CI pipeline, et cetera. You want to audit the changes to that. You probably want an alert that fires every time they're updated or there's a new one. And then pay very close attention when you do roll one of these things out to how fast the rate of denials goes up in your cloud provider audit logs. Pay attention to the inheritance and start small. So you don't want to go heavy-handed with these all at once. And there is kind of a downside to both clouds, because Google and AWS don't really give you a great way to test these things. So when you roll them out, you just have to kind of do it live and then see if the denials come in too fast. And then if it does, then you back it out. So having a way to roll these through a test system and simulate is pretty essential. The other thing that these policies don't do is retroactive enforcement. So if you decided today, for example, that you want to go in and you want to say no more static credentials, that doesn't mean because you've disallowed the API call that it's going to just delete all those static credentials. So you still have to go and audit for a lack of compliance after you enforce a control via an SCP or an organization policy. And that's where a tool like a CSPM would come into play and be really helpful for you, because it would help you scan and dashboard, and then you could just drive down the remediations over time. So with that, we've got about 10 minutes left to take questions. Before I do answer some of the questions from the chat, I just want to mention I am hiring in my team at Datadog. So if you are interested in a career in security advocacy, and you like research, and you like threat intelligence, and you like hacking on all the things and open source, definitely check out that posting. A couple of folks said that I missed a couple links in the GitHub gist. I will go back and I will add those links as well. If you have feedback on this presentation, there is a little survey on the right-hand side here. The surveys really help me kind of better tailor these anti-casts. So, give me your honest and brutal feedback. It's just like, hey, did you learn something? How did you like the presentation today? I'm also doing free cloud career coaching sessions, just a 15-minute virtual coffee that you can also sign up for. So if you're interested in that, check that box and send a desired contact information. Yeah, somebody said 11 out of 10 for the dog. There is a question, is it an internship or a full-time role? This is a full-time role for somebody that is a little bit more on the senior side of things. So if you like cloud workloads like Kubernetes and EC2 instances and fat VMs and eBPF, or even Windows, this is a job for you. So again, those are the links for today. I will just leave those up. And then I will answer as many questions as I can with the time that remains.
Awesome. So I think that did they tag you in the questions, or are we looking?
I'm back scrolling for them right now.
Let's see if in the Zoom chat, if I can pull up any.
Yeah, if you want to pick some good ones from the Zoom chat.
Somebody says, when is BarnCon, which was pretty funny.
Yeah. BarnCon is basically Wild West.
Right, exactly. And that's in October.
So folks asked a lot of questions about Azure. I hope I don't get this wrong, but Azure role assignment conditions, does this require special licensing? I don't think that the answer is yes. I don't think that you require an additional license, because it doesn't qualify as conditional access. It's actually just in their IAM policy system. Somebody tell me if I'm wrong, but they tend to differentiate the docs relatively well. So happy to, what would be a use case where ACLs would be good to use versus a bucket policy? So usually, it used to be when people used ACLs, it was because they had a big S3 bucket. They thought of S3 buckets like file servers, and they would have a ton of directories under there, and like one directory out of 100 would need to be public. So that they would just go in and they would mark individual files on upload as public files. So like one time I saw a use case for that was like coupons, like a company had private data mixed with coupons that needed to be publicly accessible. So that was a bad one to find.
Somebody says, what are the operational drawbacks of limiting long-lived credentials?
So today, I don't think that there are many drawbacks in limiting long-lived credentials. Historically, there were a ton of drawbacks in using short-lived credentials, because there wasn't this great credential dance that we could do on the command line. The user experience for engineers was terrible. And if it takes your engineering team more time, that's time that they could be spending actually developing features. If they don't like the system, they're going to find a way to bypass it. But today, the experience is actually great for developers on the command line. The other big one was access. in things that weren't that cloud environment. So like data centers that needed to access one AWS thing, they needed static credentials, but now you can use this thing that's called IAM Access Anywhere in AWS, and it's a access proxy that you can chain to X509. So if you have an HSM or something, that sort of changes that reality, and it moves those data center workloads to an ephemeral credential sort of a flow.
I'm not sure if this was covered. In your experience, how is the percentage of credential vulnerabilities caused by API problems as BOLA, BFLA, asset management, SSRF?
Okay, yeah. I don't actually know what the breakdown is. And if I read that question, it's like, what is the most prominent root cause?
Yeah.
So this is kind of like a two-part question, right? Like, so one is, how does the user of the cloud configure that thing to allow an SSRF? And then in some cases, there have actually been APIs in cloud providers that people are getting SSRFs on, and they're actually owning the cloud provider. And there were actually 3 or 4, I think, recently in Azure Cloud that was an actual problem with the Azure API and not a customer misconfig.
How could you, let me see, how could you do in order to protect you from supply chain attack in the cloud provider? Something like losing MSA consumer signing key, or letting your topic flyers use MFA and letting adversary pivoting inside.
So I'm going to just rephrase that question, which is,
okay.
if I don't trust that the cloud provider is doing the right thing, what should I do? And I would say, if you don't trust your cloud service provider, probably don't use that cloud service provider. There's also, this kind of idea of just like architecting for zero trust. And I think that is the other part of the question, is like, hey, how do I future-proof my stuff so that if there is a compromise at the cloud provider, either supply chain or somebody, runs into a data center and runs out with a hard drive, like, what do I do? And so a lot of that comes down to the way that you're storing your customer data, which, most of what's valuable that we have is customer data in cloud provider environments. So there are lots of different ways that you can leverage either your own HSM to encrypt that, make use of the cloud provider's cryptography, or you can sort of chain together a bunch of this to create zero trust kind of flows for the data storage and decryption.
Okay.
It's a little bit of the same with the IAM side of things. So MFA was the other part of that. So if you are using identity federation and that federation is not inside of that cloud provider, obviously you have a good separation of concerns. So if you move your IDP out and trust your IDP a lot, then all you have to do is trust the cloud provider to verify the certificate.
Do you recommend using a private Burp collaborator server over the default public server?
Say that one more time.
They said, do you recommend using a private Burp collaborator server over the default public server?
For Burp, like Burp Suite?
I'm assuming.
So Burp Suite is not a cloudy thing. So I'm just going to defer that question to somebody who is actually a web application pen tester.
Okay. Let's see. I think that's really.
Somebody asked, how do you sign up for the virtual coffee? So right on screen right now, I have the 2 QR codes on that feedback form is a place where you can sign up for that virtual coffee. It does take a little while, by the way. So I mail out the invites when I have more bandwidth, and then it's first come, first serve. There's like a little Calendly.
That's really cool that you do that.
I'm trying to close the cloud skills gap. It's hard to hire people right now, and there's so much opportunity in cloud security, and making the move to cloud security in 2013 was the best choice I've ever made.
Yeah, I'm sure. Those were really the only questions that I saw that weren't more of a comment type. How do you choose cloud provider tools versus the other vendors?
I mean, it's like evaluating any tool, right? So every cloud provider has some set of security solutions, though oftentimes when a cloud service provider creates a security offering, it's because a vendor hasn't filled that gap. And so we sort of see this counter-cyclical push and pull there where a cloud provider will come out with something and then the ecosystem will kind of fill in and that market will be very competitive. So generally, I think third-party tools, people put a lot of thought into the UX for those tools. I don't just say that because I work at a place that builds cloud security tools. I think most vendors that are operating in this space do spend a lot of time thinking about the user experience and genuinely how do we make engineers and security folks' lives easier, because it's hard enough.
Right.
Does Datadog work with GovCloud? The answer is yes. I believe that we're FedRAMP moderate.
Do you find this work is more often associated with IAM engineer positions, broader security engineer listings, or DevSecOps?
So yes to all of them. So I've worked at places that were larger and had dedicated IAM teams. I've worked at places where this was the SRE team's responsibility. And I've worked at places that were actually practicing what you would think of as real DevSecOps, where you're actually just having the engineers be more security conscious and implement a privileged access management model on top of all their other Terraform. So really, there's opportunities to do this work at companies of any size. And almost no one raises their hand and says, I want to be the IAM guy and do all of this.
Okay. Well, it looks like we've got a couple people typing, but I don't see any other real questions in the Zoom chat. And yes, the recording will be posted under our YouTube, the Antisyphon YouTube channel, and the live.
It's available now.
It is available now. Look, Ryan.
If you're on Zoom and you look for the resources button on your Zoom user interface thingy, you'll see a link to the YouTube. Watch on YouTube. You can find it over there.
There is a question here that says, what areas, oh, it went away. Hold on. What areas of cloud security do you think will increase in the coming years? What new areas, roles might be created? For example, incident response in the cloud security engineer.
So obviously, everything that's been increasing is going to continue to increase, right? Because adoption of cloud is increasing year over year, which is what creates this great market opportunity for all of us who kind of work as vendors in that ecosystem. But, I think this year, what's really exciting is kind of like the rise of all of the AI stuff. We talked on the news about adversarial data for AI models. So I see the opportunity for an entire specialty around just how do we secure the pipeline that trains the models? And I think that could be a really cool bleeding edge kind of area. It's not that different than anything else, but there are nuances for model training and AI.
How can we achieve zero trust security in cloud?
I mean, it depends on how you define zero trust. So the definition I put in the deck today was we're just continuously auditing the access of somebody as they continue to use the environment. So was that access appropriate? Was it overly permissive? So a KIM tool is definitely part of that. And then a good SIM that's actually looking at the session context. So did the user, do something super weird? And should we actually go and invalidate that session when it becomes anomalous? So part of it is auditing the policy, and then part of it is auditing the behavior.
And just for those of you that joined today, Andrew, your class isn't coming up anytime soon live in a live format, but we do offer the class in on demand. So we'll make sure to post a link to that, Securing the Cloud Foundations. So we will make sure to post that. And I think that's pretty much all the questions that I can see. Obviously, if you have questions after the fact, you can always tag us and we will get in touch with Andrew if he's not on Discord. So we appreciate everybody coming out and spending time with us. do you have any like final wrap up thoughts of what you covered today? Like a final takeaway
Parting
from
words.
today's talk?
So I think that the primary takeaway is that, regardless of the cloud that you're in, the same capabilities for all these guardrails and controls exist in every cloud. Don't let the perfect be the enemy of the good. This is one of those things that you just get better at over time. I think it's intimidating to a lot of people. So just like dive in and start trying to make the world a better place. And of course, if you want to reach out, never hesitate to reach out to somebody on one of these anti-casts. Like, we all love to hear from you. We love to hear if you love the content, if you hate the content, just let us know one way or
Yeah.
another. Always happy to answer questions.
Well, that's awesome. Thanks again, Andrew. We always appreciate you coming and spending time with us. And I think that's about it from our side. Do you have
I
anything
did
to
share
add,
a
Kyle?
playlist for the talking about the news because Andrew keeps
Okay.
bringing it up. So if you guys want to check
Awesome.
out talking about the news, you can see the YouTube playlist there. We do it live on Mondays, 4:30 p.m. Eastern every week, unless there's a holiday. And you can also check it out as a podcast. So if you are a podcast listener, you can search for BHIS in your podcast player thingy-majiggy, and you can find the news podcast version on there as well.
Awesome.
And don't forget to join us for the March Summit.
Yes, our the most offensive con that ever offensive. It's the bypass edition this time. So please make sure you come and join us for that. I will put a link in the chat, or if Ryan's already done that, I can't copy and
It's
paste
we have a
right now.
link in the resources,
Okay.
But you can put it in the chat
I
if you
will
want.
definitely put it in the chat. So did you have anything to add, Kyle? Did you want to talk about anything going on in your world? You're
muted, Kyle.
So
You got 7 mutes.
yeah.
I am muted. Sorry. Got kids in the background. But yes, we
We've been
have.
talking this whole time and we haven't heard.
Yeah.
It's probably a good thing, honestly. No, but if you pay what you can, training is a huge opportunity, and there aren't always those classes on the schedule. So there's a lot coming up. So if you wanted to take a pay what you can class, now is your chance. So jump on. We have SOC core skills coming up. We have active defense and cyber deception coming up. So again, it might be a couple months before we have those again, if not longer. So jump on it while you can.
Definitely. We will active defense and cyber deception starts on Monday. So
And then I think February 5th is SOC core skills. So
yep, like right after, which it's going to be a crazy couple of weeks with our pay what you cans, but we love it. So I think that's about it.
that's it.
If you have a question, definitely tag us. We'll get it to Andrew if he's not around, or if you have just a question about training or anything Antisyphon related, you can reach out to me or Kyle, and we'll be happy to help you. I think at this point we say kill it with fire, Ryan, right?
Oh yeah, here we go.